All right, in this lesson, we'll explore the apply method on a series, which calls a function on every single value that occurs within that series. So I'll be using our Google dataset throughout this tutorial. So I'm going to re-execute the code to import it and also preview the first 6 rows. So we can see our values here, 50.12, 54.10, 54.65, and so on. What if I wanted to call a custom operation on each one of those numbers? What if I wanted to, for example, classify the performance of the stock and give it one of 3 different values: okay, satisfactory, or incredible? There's no built-in method in Pandas that allows me to do that. That's my own custom design. It's my own way of looking at the problem. What we want to use here is the apply method. And there's 2 things that we can actually give to the apply method. It's expecting us to get a function, to create a function, and it's going to use that function on every single value within the series. So let's begin with the more difficult way to do it, which is to create a custom Python function. Let's create a function called classify performance. We need to begin a Python function with the def keyword for define. And this function is going to take 1 argument, which is going to be called number. You always place a colon at the end. And what is going to happen is whenever we use the apply method on this Google series, it's going to pass every value within that series one at a time to this classify performance method. So let's say I want to classify any stock performance that's less than 300 as okay. So I'm going to return okay as the final result of this classify performance function. Otherwise, if the number that the function gets passed is greater than or equal to 300 and it's smaller than 650, I want to classify that as a satisfactory performance. And finally, otherwise, I want to classify it as a incredible performance. So here we have a custom Python function written by us. This isn't in Pandas. It's our own business needs, let's pretend. And I'm going to execute the cell just so that it's live in our notebook. So now what I can do is use my Google series, which is storing those floating point values, and I can call the apply method. And the apply method, its very first parameter, is expecting a function. In this case, we want to provide it with our custom function, which is classify performance. So what's going to happen is it's going to go up here. It's going to take the very first value, which is 50.12. It's going to pass it to classify performance, get the result. It's then going to do the exact same thing with 54.10, and so on with every other value within our series. So when I execute this, we'll get a brand new series where the values will represent the results, the returns of our classify performance function that we defined in the cell above. So true to form, we can see that all of these values up here fall below 300. So whenever they're being passed into this classify performance function, they're returning okay. So that's why we see all of these okays when Google stock price is at its lowest. In comparison, if we look at the end of this new series, and we can do that with method chaining, this is going to be closer to today. So this is going to be when Google stock price is much higher. And we can see that it ends with incredible, because when those later values get passed into the classify performance function, it's going to return incredible for all those numbers that are greater than 650. So that's the apply method, and in this first example, we're passing it a predefined classify performance function. If we have something much simpler, we can also use what's called an anonymous function, and that allows us to define the function right within those apply parentheses. So for example, let's take a look at our first 6 rows again. And of course, the apply method by itself does not modify the original series. It just returns a brand new series. So just remember that. Here we have our first 6 rows. Let's say we want to do some kind of random operation, something silly and stupid. Let's say we want to add $1, let's say, to each one of these values. Now, there's much easier ways to do it, like with the add method, but just for simplicity's sake, let's just add $1 to every floating point value here. So what I can do is do google.apply, and then within these parentheses for my very first parameter, it's expecting a function, and I can define what's called an anonymous function. That means a function that doesn't have a name. It's usually used for quick operations. Whenever you're dealing with something more complex, like the example above, where we have multiple ifs and else ifs, and there's different branches and different directions that it can go, it's easiest to define that function separately. But if we have something very simple, like just add $1, we can define it directly within here using an anonymous function. The way we do that is by writing the word lambda, and we follow it with a temporary variable name. So let's call our temporary variable stock price. So what stock price is going to hold one by one is the values within our Google series. So stock price is first going to be equal to 50.12, then 54.10, and so on. Next, I'm going to place a colon, and after the colon, I define what I want to do with each stock price, and I don't actually have to write the return keyword. So what I'm going to do is just write stock price, which represents each one of my values one by one, and I want to add 1 to each value as we loop through the values in my Google series. So now we can see we're going to get 51.12 instead of 50.12, and so on for every value within our series. So you can see it operates the exact same way as a regular function does. We could have defined this in a separate Python function, but since it's so simple and it can be expressed in one line, there's really no need. We can just use this anonymous function. It's quick and dirty. So that's just the second option that we have to feed as an argument to the func parameter of our apply method in Pandas. And all that apply does is perform an operation on every single value within the series. So it's really great whenever you have some kind of custom method or function that you want to use and it's not available as one of the defaults within the Pandas library.